Maths Aspirants groups organizes online problem solving sessions to help the students who prepare for different national level competitive examinations. As a part of that series, today we have Dr. Sushmitha P, Assistant Professor, IIT Patna, with us to handle a session on Part A questions for CSIR net. As the next net examination is scheduled in the coming December, I hope that today's session will be really helpful for all those who are seriously preparing for different competitive examinations. Dr. Sushmitha did her Ph.D. from IIT Madras, and her broad research area was linear algebra and optimization. Sushmitha studied her BSc from Bharatidasan Government College for Women, Puducherry, and MSc from Pondicherry University. And she qualified CSIR, JRF with All India rank 87 and GATE with All India rank 19. So I'm sure that we have today really blessed with a great resource person who is in all the way will be able to help you in your competitive examination preparations. So I hope that everyone will enjoy today's session, and welcome. I would like to thank Sushmitha for accepting our invitation and joining with us. Welcome everyone to this program. Welcome, Sushmitha.
Thank you, sir. Thank you so much. So, thank you for giving me the opportunity to speak with them, and it's a really nice initiative that you had started, and it's nice to see that it's still going on. It's not, it just didn't end with the COVID thing. It is still going on. So it is, I'm sure it helps a lot of people, and that is why we see that every session there is a lot of people joining the sessions live as well as on YouTube also. It is being watched. Okay, I guess I will just get started right away. I am no expert in solving logical questions or puzzles or anything, but the ones that we get in net exam, that is not very difficult, in the sense that if you just spend maybe a minute on each question, you should be able to solve all the questions. And you have only 20 questions, of which you have to answer only 15 questions. So you can just spend like 20 or maximum 30 minutes on the Part A questions, and you can start solving the other math questions. Yeah, let's discuss a little bit of strategy or something later on after we discuss a question paper. My plan for today is I've just taken a recent question paper, and then we will try to solve the Part A of that question paper completely. Because if we do topic wise, like logical reasoning of each paper or puzzles of each paper, then I don't feel it will do justice to what we actually intend to do. So my aim is, if you are a person who skips Part A and who doesn't want to attempt Part A just because you think that you are not capable of doing it, I just want to change your mindset a little bit, that yes, even I can do Part A, let me try it out this time. Okay, so when to try, at what point during the exam you should try, and all that, maybe we can discuss that after we discuss the questions. So let's start with by solving one question paper. I've just picked one question paper, so we'll have 20 questions. Let's try and solve this paper. So this is the February 2022 paper. I guess there was 1 or 2 exams after that. I just randomly picked this paper. Is my screen visible to everyone?
Yes, ma'am, visible.
Yeah. Okay. So, and one more thing, it will become a very boring session if I keep talking. So maybe we can have an interaction. And this is what I am trying to solve, is just my point of view of solving the problem. maybe you have a much simpler and better point of view. So it'll be better and nice if we can discuss and solve the problems. Okay, so let's get started. So the first question is, section A has 24 students. If one student of this section is exchanged for another student in section B, then the average mark of A is increased by 1.25, while that of B is reduced by 1. The number of students in section B is asked. Okay, so there are two sections. One is section A and the other is section B. And there are 24 students here. And we don't know how many students are there here. That is what we want. So let me call it NB. N denotes the number of students, NB. That is what we want. The number of students in section B is what we want. Okay, so what is happening? If one student of this section is exchanged for another student in section B. So there is one student that goes to this section and one student from here that comes to this section. Then what happens? So when one student goes from section A to section B, the average mark of section A is increased by 1.25. And when this student goes from B to A, the average is decreased by 1 mark. What is the total number of students? So how do you think we should do this? So what should we do here? When the student exchange is happening, one thing to be noted is the total number of students in A and the total number of students in B is not changing, right? So one is going, but one is coming instead of that person who is going. So what do we do? How do we do? Anyone? You can just try. There's no need that you should have the answer or you should have the correct approach or anything. You can just try. That is what you should do in the exam hall as well, right? Whether you know the answer or not, only if you try, you will know whether you can solve the question or not. So, anyone wants to attempt? Or are you all shy because it's the first question? Let me pick a random name and then ask what is the approach. Will that be okay? Anushri Chandran, are you there? Or is it because it's Sunday morning, you're all having breakfast and that is why you're not talking?
Hello.
Yes. Can you give an attempt to this problem? What do we do?
Mm,
Yeah, go ahead.
we use the method of finding the average,
Okay.
but I don't know how to proceed.
No, why don't you give a try? What is the average of A? Do we know the average of A?
We don't know, but it is if we take it as some unknown value, then it is increased by 1.25.
Okay, but we don't know what the average is, but we know that it is the total marks obtained in A divided by total number of students in A, right? 24.
Yes.
Similarly, I know the average of B is total in B divided by the number of students in B. That is what we should find out, which we have called NB. Okay, so this much we know. We'll see if we can figure out what is what. If we don't need all this actually, right? As long as we are able to find NB, that is the goal. So let's see what happens. Then what happens? What is the new average of A after one person leaves and the other person comes in? So let's call, say if Anu is leaving this class and I saw some other name, Aishwarya. Aishwarya is coming into this class. Anu is leaving section A, Aishwarya is coming into section A. What is the new average of A? Do we know any relation between the new average and the old average? What happens to the average when Anu leaves and Aishwarya enters? Anyone? Okay, maybe I will solve this problem, but from the next one, I'm not going to give up. I'm going to make you all speak. So what happens when Anu leaves and Aishwarya enters? The average of A increases by 1.25. So the new average of A is whatever was the old average plus 1.25. And now what is actually happening here? So the total of A, that is being disturbed, right? The total number of students is the same, but the total marks is being disturbed. So initially we had a total which included Anu's marks, but now Anu is not there, minus Anu's marks. But instead of Anu's marks, Aishwarya's marks are there, right? This is the total, new total now, and that is divided by 24 because the total number of students remains the same. One leaves and another enters. So the total number is not being disturbed, but the total marks obviously is going to change because initially Anu was contributing to the total, but now Anu is not there. Instead, Aishwarya is there. So you remove Anu's marks and then you add Aishwarya's marks. So this is the new average. So now since we know a little bit of substitution, some calculation, we know some relation, we'll try to figure out by cancelling out certain things and all that. So what is, now I'll just substitute here. Average of A is what? Total A divided by, total of A divided by 24 plus 1.25 is total A. I'll again divide it by 24 separately so that I can cancel it out. Minus Anu by 24 plus Aishwarya by 20. So I can cancel out these two terms. So what information do I have now? Aishwarya minus Anu. That is the marks obtained by Aishwarya minus the marks obtained by Anu is 24 into 1.25. So this is one information that I get from the first section. That is dealing with the first section alone. Now similarly, I can do the same thing for the second section. So what happens in the second section? The new average of B is old average of B minus 1. The average is going down by 1. So what is happening here? Total minus Aishwarya is going out and Anu is coming in. So Aishwarya is going out and Anu is coming in, divided by the total number is NB. That's not going to change. Again, when we simplify this, what do we get? Average of B is total B divided by NB. So total B divided by NB minus 1 is total B by NB minus Aishwarya by NB plus Anu by NB. Our aim is to find NB. So these get cancelled out. And what do we get? Minus NB is Anu minus Aishwarya. But we already know what is Anu minus Aishwarya, right? Aishwarya minus Anu is 24 into 1.25. So Anu minus Aishwarya is going to be minus 24 into 1.25. So NB is 24 into 1.25. That's what? 24 plus 1/4 of 24. 30, right? 30, one of the options, yes. So what is actually happening? So you can do a lot of calculations. See all this calculation that you take, write down and simplify and all that. In the exam, you needn't do so much, right? You can just straight away write down some, instead of Anu, Aishwarya and all that, you can just say some A and B, and then you can reduce the time of all this calculation and unnecessary wordings by reducing the number of alphabets. For example, instead of writing total A, you can write TA, because in the exam hall, you're just going to look at that question for, say, a minute or so. And as long as you understand what is being written, that is enough, right? So instead of writing total A, you can just write TA, or if you want, you can write what, sum A, sum of the values in A and all that, something like that. So that way you will just not be writing so much for one question. And while doing this rigorous calculation, what did we notice? So see, when Aishwarya is leaving and Anu is coming in, that is happening in section A, the average is decreasing by 1. So what is happening here? Decreasing by 1. So minus 1 into the number of students is equal to Anu leaving and Aishwarya entering. Oh, sorry, Anu entering and Aishwarya leaving. Minus is for Aishwarya. So Aishwarya is leaving and Anu is entering, right? And this is the difference that you're getting. That is minus 1 times the number of students is the difference caused by Aishwarya's exit and Anu's entry. Similarly, Anu's exit and Aishwarya's entry into section A is increasing the average. So what is basically average? Average is what? Some kind of a middle value, right? It's a central value that you're trying to calculate. So one thing, if every value in section A increases by 1.25, the average is going to increase by 1.25, right? But that need not always be the case. All values need not be the same, or the increase in all values need not be the same. But the entry of Aishwarya is making an effect in such a way that all the values are being increased by 1.25. The average is being increased by 1.25. So that's what is happening here. Aishwarya's entry and Anu's exit, Aishwarya minus Anu, is going to cause all the values in section A to increase by 1.25 in some sense, right? The average is increasing by 1.25. So 24 into 1.25. The total increase in A will be equal to the total decrease in B, right? That's what is happening, right? Aishwarya minus Anu is 24 into 1.25. Anu minus Aishwarya is minus 24 into 1.25 when you just do the simplification. So the total increase in A is same as the total decrease in B. So you can just, you can skip all this and then directly go to that. 24, the total increase in A is equal to the total change in B basically. The change in B is decreased by 1, right? Oh, okay. The total increase in A is equal to the total decrease in B. So the decrease is by 1, right? So it will be NB into 1. So this way also you can straight away solve for NB. But there is no need for you to understand all this or know this. If you just know how to calculate the average and what is the information given, you can just go ahead and solve this problem like this. And this is not going to take you more than a minute to solve. So this is a good question to attempt, in the sense that even without knowing any basics, just by knowing how to calculate average, you are able to solve this question. So you should definitely attempt this question. Unless you're making some calculation mistake and you end up with the wrong answer, you are safe with this question because it's a simple and easy question to solve. Okay. So let's pick someone to solve this question, unless someone wants to voluntarily solve. The square of a 2-digit number with non-zero digits is the number itself preceded by the digit C. Then what is C? Who's going to solve this question? Or at least tell me what is given in the question and what is asked. Someone? If no one volunteers, I will make someone volunteer. Shivjit, are you there? Vandana? Shivjit is there. Okay, yeah. Yes, Shivjit. Would you like to attempt solving this question?
Yes, ma'am. Actually, the given thing is the square of a two-digit number.
Hmm.
Okay,
So I have a two-digit number, say AB. Okay.
Then with no digits, no zero digits are there. So A and B are not zero digits.
Okay.
Then the number of itself preceded by the digit C.
Hmm.
So then what is that preceded digit? That's the question.
So what is AB squared here?
AB square is a number with three digits, right?
And what is that number? Do we know what that number is? CAB, right?
Yes.
It is the number itself, that is AB itself, preceded by C. Okay.
Yes.
So AB squared is CAB. Okay. How are we going to solve this? Any guesses on what B can be or B cannot be? If we know A and B, we can find out C, right?
Yes, ma'am.
Yeah. I have a number A, B, and then I have to multiply it with itself. So the
Yes,
last digit of the product is going to be the product of these two. The last
Same.
digit of the product of these two, right?
Yes, ma'am.
Yeah. So B squared should end with B. It can be some other number and B,
20,
but it should end with
25 square, 625.
Right. Okay. Since you are able to observe it, it is straightforward here. Yes, 25 squared is 625. So C has to be 6, right?
Yes, ma'am.
Yeah.
Thank you.
But what if we were not able to guess? Thank you, Siddharth. Thank you so much for answering. So what if we were not able to guess 25 squared? Right. Okay. We can think, means we know that 25 squared is 625. But anyway, let's assume that during the exam hall, we didn't get it immediately. So what do we do? So this is also not going to take much of a time. One thing we know, AB squared should be CAB. That is AB into AB should be this number. That is this B squared. The first thing that we will do to multiply these two digits is, these two numbers is B into B, right? That is going to be this digit. So B into B, whatever B squared is, and then B into A. We might have a carry forward and all that, but whatever it is, the units digit, after this, there won't be anything, right? The units digit is going to be B squared. That is the units digit of B squared, right? So we need to first look at those numbers which are going to give, whose squared is going to give the same unit digit. So what is 1 squared? 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. So of which I just need to pick those numbers whose squared gives the same number as the units digit. So this is working. B squared is, B squared ends with B. So it works. This is not happening because 2 squared does not end with 2. This is not a candidate. 3 squared, no. 4 squared, no. 5 squared, yes. Because 5 squared ends with 5. 6 squared ends with 6. So this is a candidate. 7 squared, no. 8 squared, no. 9 squared, no. So we have ruled out of the 9 possibilities, we know that B can either be 1, 5 or 6. Now what happens if B is 1? Even with this, I guess we would have probably guessed 25 by now. But let's assume we are still not there. So what happens if B is 1? So if B is 1, now this simplification happens. I know one of the numbers, so I have A1, A1. So A1 into 1 is 1, and then I'll have A here, and then A squared here. So this is 1. The last digit is 1. And then I have a plus a, which is 2a. 2a may be just 1 digit or it may be 2 digits also. Say, for example, if a is 5, then 2a is going to be 10, right? So I'm going to get a 0 here and I'll carry forward a 1, but it's okay. We can keep it as it is for now. A squared, if there is a carry forward, I'm going to add it with that, right? So suppose 2a, okay, so now what? This is b, this is a, and this is c, right? 2a should be equal to a. This is never going to happen, right? The unit digit of, okay, so what is happening here? This a, okay, if the unit digit of 2a is here, I would have carried forward the tens digit and all that. So you can keep that in mind. So the unit digit of 2a and the unit digit of, or the unit digit of 2a and a should be the same. 2 times 1 is 2, 2 times 2 is 4, like that, right? 2 times the number should end with the same number, right? So 2 times 3 is 6. One thing, I can immediately conclude that a has to be even from here, right? A cannot be odd, because if it's an odd number, 2 times that odd number is going to be an even number and it's never going to end with the same number, right? So I can eliminate all the odd possibilities and I needn't even calculate all the odd numbers. So 2 into 2 is 4, 2 into 4 is 8, 2 into 6 is 12, 2 into 8 is 16. That's it. I don't want 2 into 9, right? 2 into 2. If a is 2, 2a ends in 4, which is not a candidate. If a is 4, 2a ends in 8, which is not a candidate. If a is 6, 2a ends in 2, which is not a candidate, because 2a should end with the same digit a. 2 into 8, this is also not a candidate. So none of these possibilities are going to work if b is equal to 1, right? So b cannot be 1. Next we go for 5. B is equal to 5. So now if b is equal to 5, then I have a5, 5 5s are 25. And then I'll have 5 into a plus 2. This is this digit. And then I'll have 5a, and then I'll have a squared. So here I have 5, which is my b. 5a plus 2, 5a plus 2, 10a plus 2. This is my a, and this is a squared. So now what happens? The last digit of a, or a should be equal to the last digit of 10a plus 2. Is that possible? 10a plus 2 and a should have the same last digit. If this is possible, then that's going to be one of the candidates for a, right? And if we have got a candidate for a, since we already have a candidate for b, which is 5 in this case, I have a candidate for ab, right? So is this possible? Put a is equal to 1. So when a is equal to 1, the number should, a is 1. 10a plus 2 is 12, which is not a candidate, right? Because this ends in 2, but I want it to end in a. And then 2. When a is 2, 10a plus 2 is going to be 22. This is a candidate, right? And this is the only candidate, right? Because when I take a to be any other number, 10 times a is always going to end in 0, plus 2 is always going to end in 2, right? So this is the only candidate that I have, right? 2 is the only candidate, right? So a has to be equal to 2, and b we already have started with 5. So if a is 2 and b is 5, 25 squared is 625. So that is what we observed earlier. If you're able to observe, if you get in mind that 25 squared is 625, this problem is over in a second. But even otherwise, you can attempt. Or even if you don't want to go by this trial and error method, you can go by algebraically solving. You want ab squared to be equal to cab. ab squared is what? 10a plus b, the whole squared, should be equal to 100c plus 10a plus b. So you can take this to be some x. X squared is 100 times c plus x. So after coming here, okay, x squared minus x should be 100 times c. You needn't check for all c. Possibilities for c is given 1, 2, 4, 6. These are the only possibilities for c. So when c is equal to 1, x squared minus x should be equal to 100. Can you find a number x such that x squared minus x is 100? That is the question. When c is equal to 2, x squared minus x has to be 200. Can you find a number x such that x squared minus x is 200? So that is what you have to check for all the candidates. C is equal to 4 and C is equal to 6, right? Yeah. So x squared minus x has to be 400 here. X squared minus x has to be 600 here. Is it possible to get a number whose square, the difference between the square and the number is 100? How will you check this? This is again by trial and error, right? You can do what? 9 squared. Oh, 9 squared itself is not 100. So you have to go beyond 9 squared, right? So 10 squared. 10 squared is 100. So if you're subtracting 10, you're not going to get 100 as the difference. So 11 squared. 11 squared is 121 minus 11. It's greater than 100. So this is not going to happen for any possibility, right? If 11 squared minus 11 itself is greater than 100, 12 squared minus 12 and all will be much greater than 100, right? So this is never going to happen. Is 200 possible? What is 200? 14 squared is 196. That's less than 200. So 15 squared. 225 minus 15, right? 225 minus 15, which is not 200. So this is not going to be a candidate. For 400, 20 squared. 20 squared is 400. So you have to check 21 squared minus 21. So you can check that way. This is not going to be 400. And this will be possible because you'll get 25 squared minus 25. That's going to be 600. So this is another way of approaching the problem. But I would say that you can spend some time on this problem. You can take a minute to solve it because it's not very difficult in the sense that if you're able to attempt it, you're definitely going to get the answer. It's not like and there's no calculation error that you're going to do here because you can finally check if the answer that you've got is right or not. So this is definitely one problem which you should attempt because if you get the answer, you're definitely going to get the right answer. Okay. Now the next question. A and B have coins. Okay, A has some coins of rupees 1, 2, 5 and 10 in the ratio 4:3:6:2, and B has 3:5:7:3. A has 6 rupees more than B. Which of the following can be the number of coins with A and B respectively? Okay, who is going to attempt solving this problem? Anyone wants to attempt? No, nobody wants to attempt solving this problem. What does it mean? What does ratio mean actually? 4:3:6:2. What does it mean? A has 1, 2, 5, 10. This is the coin denomination. The ratio is 4:3:6:2. So what does ratio mean? If A has 4 1-rupee coins, then it has 3 2-rupee coins and 6 5-rupee coins and 2 10-rupee coins, right? Or if A has 8 1-rupee coins, how many 5-rupee coins does it have? If A has 8 1-rupee coins, can we tell how many 5-rupee coins it has?
12.
Right. So that is the concept of ratio, right? So it's something like what? 4x, 3x, 6x, 2x, right? So we don't know the exact number, but we know what is a ratio. like what is the relation between the number of coins of denomination 1, 2, 5 and 10, right? So if A has 4x 1 coins, 1 rupee coins, then it's going to have 3x 2 rupee coins. So if A has 8 1 rupee coins, then it's going to have 6 2 rupee coins, right? So that is the meaning of ratio. So what is the total number of coins A has? 4 plus 3, 7, 13, 15. 15x coins A has, right? So this is the number of coins of A. But what is the value of these coins? 4x. 4x times 1 rupee coin means 1 into 4x. 4x. 3x times 2 rupee coins. So the value is 6x. So say if x is 1, then it will be 4, 3, 6, 2. So if I have 4 1 rupee coins, then my value is 4 into 1. 3 2 rupee coin means I have 6 rupees. 6 5 rupee coins means I have 30 rupees. And 2 10 rupee coin means I have 20 rupees. So that way, 6x, 6 5 rupee, 6x times 5 rupee coins. So 30x. And then 10 2, 20x. So the total value of the coins that A has is 50, 60, 60x. Okay. Is there any option that we can rule out with this information? The number of coins A has is 15x. So with this information, can we rule out any option? The options talk about the number of coins of A and the number of coins of B.
We can neglect 42, ma'am, option B.
Right. We can ignore 42 because NA, the number of coins A has is 15x in the sense that it is a multiple of 15. 42 is not a multiple of 15, so you can ignore that. B, C, D, everywhere else we have a multiple of 15, so we cannot ignore any of those options. But let's check what is NB. NB is similarly 3y. We need not take the same x. The ratio may be different, right? Instead of A can have 4 1 rupee coins and B can have 6 1 rupee coins. So the x and the y need not be the same. So if x is the number of coins A has and y is the number of coins B have, like that we can start. So 3y plus 5y plus 7y plus 3y, that is 10, 18, 18y. So with this, can we eliminate any option? Unfortunately, no. All the numbers n, b are divisible by 18. Okay, so that is not something that we can do. Okay, so we have to proceed next to see what is happening. We have A has 6 more than B. So we have to see what is the value that B has. Value that B has is 3y times 1 rupee coins. So 3y plus 10y. 5y times 2 rupee coins. 7y times 5 rupee coins. And 3y times 10 rupee coins. That is 30y. So this is 30, 40, 70, 75, 78y. The value that B has is 78y. And what information we have? A has 6 rupees more than B. So the total value that A has is 6 rupees more than the total value B has. With this information, can we do something? If we get x and y, we are done, right? Because if we know x and y, we know what is 15x and 18y. That is what we have to do. So I can simplify this. 6, 13, right? So 10x is 1 plus 13y. So I need to find an x and y satisfying this equation. So I need to find a multiple of 13, which is just 1 less than a multiple of 10. 39, right? 39 plus 1 is 40. 13 1s are 13, 13 2s are 26. 26 plus 1 is 27. 13 3s are 39 plus 1 is 40, right? So y should be 3 and x should be 40, 4, right? 10x should be 40 So X has to be 4. This is one of the candidates. Okay, let's check if this is one of the options. If this is one of the options, then we are done, right? So what is the total number of coins? What is NA? If X is 4, NA is 60, right? NA becomes 60. And if Y is 3, NB becomes 18 into 3, 54. Is that an option? Yes. So maybe there are other numbers which satisfy this equation. Obviously, there will be other numbers that satisfy this equation. But I need the biggest number that I can get is 60, right? Means among the options, the biggest number of NA, that is 15x, is 60. So X can be at most 4 according to the options, and we have already reached that 4. So we needn't go beyond checking any of the options. And not just that, in part A, you have exactly one right answer. So why would you, once you've got one right answer, why would you go for other options, right? So that's one way of looking at it. And yeah, so with that, you have got the answer. And this is also, I would say, is a question which you should definitely attempt, because if you get the answer, you are going to get the right answer. Is this clear what is happening here? I think I've been speaking for a really long time. So I don't know if it's clear to you people.
Yes, ma'am, it's clear.
Oh. See, more than solving the problems, I hope you understand that my aim is not to solve this paper. You would have probably solved this already on your own. But the aim is to tell you that it's not going to take so much time to solve these questions, and hence you should attempt it. That is the aim. Okay. So this question, 6 indistinguishable balls, that is identical balls, right, are to be distributed among A, B, and C such that each one gets at least 1. Then the number of ways to make this distribution is. Okay. So what do you think is the mathematical concept behind this problem? Ways, number of ways to distribute some object. Permutation combination, right? So you will check for how many ways you can distribute an object between a certain number of people or something like that, right? So it's not necessary to know permutation combination for this. Basically, I am also not an expert. Most of the times I won't understand where to apply what and what is the means with replacement, without replacement, and all that. It doesn't figure out that easily in my mind. So what I do is and since this is a really small number, the number of objects to be distributed is only 6. So we can just list out all the possibilities and we can count how many ways it is possible, right? Since all the 6 balls are identical, I can start with one object and then distribute, means I have to give each one at least 1. So let's assume that I'm giving A only 1. I have to give at least 1. So let's start with that possibility. If I give A only 1, I have to give the remaining 5 balls between B and C. And what are those possibilities? I cannot give 0 to one of them. So what are those possibilities? In how many ways can I give B and C 5 balls?
We can give B 1 ball and C 4 balls.
Yeah. And then what are the other possibilities?
Then we can give B 2 balls and C 3 balls. The same can be repeated by interchanging them.
Yeah. Right. So you can fix for A. Say I'm giving only 1 ball to A. Then the remaining 5 balls has to be given to B and C. These are the only possibilities in which I can give it to B and C. Now, the next step. Okay, I'm giving A 2 balls. That is also possible, right? So if I give A 2 balls, what happens? I have 4 more balls left, and those 4 balls have to be given to B and C, right? So that may be given in 1:3, means 1 ball to B and 3 balls to C, or 2:2. I can give 2 balls each. Again, if I give 2:2, it's the same, right? I needn't put this 2:2 here. It doesn't matter because they're all identical balls. It doesn't matter. So this won't be a case. I can give 3 balls to B and then 1 ball to C. This is all the possibilities when A is having 2 balls. Now, when A is having 3 balls, I'm left with 3 balls that can be distributed as 1:2 or 2:1. These are the only possibilities. And the other possibility is when A is having 4 balls. When A is having 4 balls, I have only 2 balls left to give. And both the balls, each person has to get at least 1 ball. So it is this. And can I give A 5 balls?
No.
No, we cannot give A 5 balls. That's because if we give A 5 balls, I have only 1 ball left to give. So one of the remaining 2 will not get any ball. So that is not possible. So these are the only possibilities. Just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's it. This is just logic. So with this logic, you should be able to solve. But you should be careful not to miss out on any of the possibilities. So you have to be a little careful with this question. But it's an easy question. You should just be make sure that you're covering all the possibilities. It's definitely not, if you've got 10, it's definitely not going to be 18 and all because it's too much more than 10. You have almost, here you've covered all the possibilities, but even if you're going to miss out, you're not going to miss out on 8 possibilities and all that. 5 possibilities is also a big thing to miss out on. So 10. Okay. A book has 40 pages and each line has, each page has X lines. The number of lines were reduced by 2 in each page. The number of pages would increase by 10 for the identical text. What is the value of X? I don't think I even need to solve this problem, right? This is just like, it's going to take you a second to write down the equation and another second to find the value of X, and in 2 seconds you'll be done with this problem. So a book has 40 pages and each page has X lines. So 40 pages, X lines. If the number of lines were reduced by 2 in each page, so instead of X lines, you have X minus 2 lines, then the number of pages would increase by 10. So instead of 40, you will have 50 pages for the same book. You have to find the value of X. So I think this is straightforward, right? 40X minus 50X is minus 10X is minus 100, right? Yeah. So X is 10. So if you're scared of part A and you plan to skip part A, imagine what a simple problem you have skipped, like 2 marks. That's going to make a huge difference. So you should definitely not skip any question. In fact, not just in part A, you shouldn't skip any question in any part. The best way, means the easiest way to maximize your score is when you have read all the questions in the question paper at least once, because you never know where a simple question is hidden. You might think that I don't know this topic, so if it is from that topic, then I'm not going to attempt that question at all. But it may be a very simple logical question which you can attempt and get marks for that question. So you should, the best thing is read all the questions in the question paper, and you might, if you're lucky, you might find questions that are easy, but it is also, there are no questions that are easy in topics that you don't know. Say for example, algebra, abstract algebra. Like for example, let me give my own scenario. I never used to do much of abstract algebra. I was always into the linear algebra, real analysis, complex analysis and all that. So I never used to do much of linear abstract algebra, but there are some standard formulas, right? Like find the number of abelian groups if the group is of order PQ and all that. So there'll be some formulas. I don't remember anything right now, but there'll be some fixed formula, right? So if I had thought that, okay, this is an algebra question, I don't know how to do, and skipped it, I would have lost marks. I wouldn't have gained the marks that I got there. So since it's just one formula, and if you know that, why not attempt it, right? And not just that, probability statistics. Like most of us skip that statistics, probability statistics part. But maybe there is a question which is as simple as a question which talks about an impossible event, and they're asking what is the probability. So you need to think about, if you know the logic behind it, and if you know that it is an impossible event, then you can just write down that the probability is 0, right? So you shouldn't skip any part thinking that, okay, I haven't studied this, I don't know. Maybe it is a very, very simple question that has come from that part. You should read all the questions. Just for example, if you were going to skip part A, imagine this question is nothing at all. In 2 seconds, you can solve this question and still you would have missed out on. So read all the questions in the question paper. Yeah, and you always get questions of this type where you're given a graph or something and then you're asked some inference out of the graph. Those questions are very, very simple. So you should definitely attempt it. But if you have a doubt at any point, don't attempt it because you're going to get negative marking. If you're not, but the chances that such questions are very simple that you should definitely be able to solve them. So if you have a doubt, then don't attempt it because you are going to get negative marks if you get a wrong answer. But that doesn't mean you don't read the question. So yeah, this question, the figure shows the result of an experiment in which cells of a certain bacterium were grown in different nutrient concentrations while keeping all other parameters constant. Okay, so there is an experiment that is conducted and then you have different nutrient concentrations. So you're changing the concentration of certain nutrient or different nutrients, and then you're seeing how the bacteria grows in it. Which of the following inferences is correct? So for such questions, don't try to analyze what the graph is telling. First, go to the options and then look for the graph. Nutrients do not have any role in cell growth. So it is saying whatever be the nutrient I give, it does not affect the growth, the cell abundance that is written here. Is it correct? Are nutrients having a role in cell growth? From this image? So this is the nutrient axis and this is the growth axis, right? So as we keep increasing the nutrients, we see that there is a change in cell growth, right? So initially from 0 to 4 up to whatever, 6 or say 5 or something. From that point 0 to 5 or 0 to 6 or whatever, there is an increase, right? As you increase the nutrients, the growth is also going to increase. But beyond that, how much ever you increase the nutrient, it is remaining a constant, right? And then if you increase more, if there is too much, it is also going to destroy the cells, right? It's reducing. See, the cell growth is decreasing when the nutrient is too much. Too much of anything is not good, right? So that is happening here as well. So nutrients do not have a role in cell growth is wrong. There is a linear increase in cell abundance at low nutrient concentrations. That's right. So there is a linear increase. See, there is a linear increase here at low nutrient concentration. So this is a possible answer. Cell abundance was limited by the availability of nutrients, but a high nutrient concentration seems toxic for the bacteria. Right. Cell abundance was limited by the availability of nutrients. So as the nutrients kept increasing, the cell abundance was limited after some point of time, but high nutrient concentration at the higher level, it seems to be toxic for the bacteria. Yes, that is why the cells were dying, right? So this is also an option. Cell abundance decreased rapidly once nutrient concentration reached 5 micromole per liter. At 5, it didn't decrease, right? It's decreasing rapidly, they are saying. It didn't decrease. It was remaining constant for some time. And then it started decreasing. So this is not an option. So B or C, which one? Which of the following inferences is correct? You have to check which one is correct. Both of them seem to be correct, so you have to choose the most appropriate one. The most appropriate one is C, right? Cell abundance was limited by the availability of nutrients, but a high nutrient concentration seems toxic for the bacteria. This option talks about the entire graph itself, whereas option B talks only about the low nutrient level. So the better option, the one that talks completely about the, with option B, you cannot tell that bacteria die with more nutrient concentration. Whereas with option C, you can tell anything that is happening in the entire graph. So option C is right. So there'll be a question of this kind, which is again answerable within like 10 seconds. You just have to read the options and then you have to see. But before reading the options, you have to check whether they're asking for the correct answer or the incorrect answer, and then accordingly proceed. You have to read the options and then you can check for what the graph says and then choose accordingly. So these are also simple questions which definitely need to be attempted. Okay, this is a geometry question. As shown in the figure, a chord AB of unit circle of unit radius. Okay, so you have 1, OA, OB is 1. Subtends an angle of 90 degree at the center. So this is 90 degree. The area of the shaded region is. So how do we do this? What is the area of a sector? This is a sector, right? This entire portion is a sector. If I know the area of this sector, then I can remove the area of this right angle triangle and then get what is AB. What is the area of a sector? Anyone knows what the area of a sector is?
Theta divided by 60 into pi r square.
Theta by 360 into pi r square, right? This is the area of a sector. The theta given here is 90 degree. This angle is 90 degree. So 90 by 360 into pi r square. R square is 1 square. The radius is 1. So what is this? Pi by 4. Now I want the area of this shaded region. So I need to remove the area of this triangle. I know it is a right angle triangle, right? O is 90 degree. A, B, OA is 1, OB is 1. So this has to be root 2. Area of the triangle is half into base into height. In fact, I don't need what AB is at all here. Half into base into height. So this is half. So area of the shaded region is pi by 4 minus half. That is 1 by 4 into pi minus 2. So after you get to this point, you just see how the options are looking. Pi does not have a denominator. So just take whatever is the denominator of pi common out and then accordingly simplify. This is one way. But what if I don't know the area of a sector at all? I don't remember. This is something that I learned in school and I don't remember the area of a sector. So how do we solve this problem? How do we know that the area of the sector is pi by 4 without knowing the formula for area of a sector? At least when I solved, I didn't remember what the area of a sector was.
Actually, the area of circle here is pi. So we can divide it to 4 since the angle here is 90.
Yeah, that's it. So the entire angle here is 360 degree, of which this portion is 90 degree, right? So I can divide it into 4 pieces, each of equal area. So this is 1/4 the area of the circle. Area of the circle is pi r squared, that is pi, right? R is 1, so pi. So pi by 4 minus the triangle thing is the same. So half into base into height. So that way also, even without knowing this formula, you can solve this problem. This is again going to take you a maximum of 30 seconds to solve the problem. So definitely you should attempt such problems. Okay, so here is a logical puzzle. 6 persons, P, Q, R, S, T, sit around a circular table. Okay, so there is a circular table. And then there are 6 people, P, Q, R, S, T, U. With equal distance between neighbors. Okay, fine. So we can probably draw a hexagon inside, and then at each corner of the hexagon, there's going to be one person. 1, 2. Okay, for a hexagon, there's a bad image. First, let me draw a hexagon. Yeah. So 1, 2, 3, 4, 5, 6. So PQRST sit on this table, equidistant and all that. P is immediate to the left of R. So P is somewhere here. P is to the left of R, to the immediate left of R. So R has to be either here or here. They are all sitting in a circular table, so they are facing inward. So if R is here, this is the right of R. So R has to be here, to be to the left, right? The left of R is P. T and S do not sit next to each other. Okay, we don't know any information about that, but we know T, S do not sit next to each other. T and R are diametrically opposite to each other. So if R is here, T has to be here. So S cannot be here, S cannot be here. So the only possibility is S is here. So we have figured out where T and S, P and R sit. Which of the following is not possible? So who are the left out people? P, Q, Q can be here, Q can be here, R, S, T, U. U can be here, U can be here. Q and P are sitting diametrically opposite to each other. This is a possibility, right? If Q was here, then Q and P would be sitting diametrically opposite to each other. So it is possible. P and U are sitting diametrically opposite to each other. Again, if U was here, P and U would be sitting diametrically opposite. So this is possible. S and T are sitting diametrically opposite to each other. No, right? S is diametrically opposite to Q or U, and T is diametrically opposite to R. So S and T are never sitting diametrically opposite to each other. The other one is S and Q are sitting diametrically opposite to each other. That is a possibility. If Q was here, then S and Q would be sitting diametrically opposite. So that is a possibility. So the only thing which is not possible is S and T are sitting diametrically opposite to each other. So this is also going to take a maximum of 1 minute for you to solve this. Read all the information, draw the figure, and then look at the options. You will know which one is right, which one is not right. So these are questions which you should definitely attempt. Okay. The number of dates between 1st January 2000 and 31st January 2020 when written in the DDMMYY format. Okay, DDMMYY format that read the same from left to right are okay. So you need to look at almost 20 years or 21 years, and you should write all the dates in DDMMYY format, and they should read the same left to right. So Y, 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 M, M, D, D. They should read the same left to right and right to left. But some example is given here. 12 February 2021. So 12/02/2021. If you read it this way or this way is the same. 1 to 12/02/2021. How many such dates are possible? That is what you should check. Okay. So how do we start? Do we start with dates, months, or do we start with years?
We should start with year, month.
If we start with the date and month, then I should start with every date, right? Like I should start with 01/01/2000. And I should check if it's going to satisfy or not. But if I start with 2000, it's going to be simpler to solve the problem, right? If I start with the year, then I know what should be the date that we are looking for, right? Because if I start with 2000, I know what these 4 digits should be, right? What should be these 4 digits? If I go from the left or from the right, it should be the same number that we are talking about. So if I go from the right, it is 0002. So from the left also, it should be 0002. Is such a date possible?
No.
No, there's no date which starts with 00, right? So this is not at all possible. So in 2000, I'm not going to get any date which satisfies this condition, right? Is that clear? Because if the year is 2000, then the first 4 digits have to be this, because they have to read the same from left and right. So this is the only possibility, and this is not a date at all. So 2000, not possible. 2001, what will be the date here? It should read the same from left to right and right to left.
Possible.
The date is going to be 1002, right? So you read it from left to right or right to left, it should be the same. Whatever you have A, B, C, D, you just have to write it in the opposite direction. D, C, B, A. D, C, B, A, A, B, C, D. That is your date. If this is the year, then D, C, B, A, A, B, C, D. This is the date we are talking about. If such a date is possible, then you're done. So start with the year A, B, C, D and then find out what the number has to be. So 2001, it is possible. 2002, it's going to be 2002. Such a date is possible. What about 2003?
Possible.
No, 2003 is going to be 3002, right?
Not possible.
So February is not going to have 30 days anyway. So this is not possible. 2004?
Not possible.
Yeah, you're going to get 40. So 2004, 5 means you'll get 50 as the date. 6, 7, 8, 9, none of these will become possible, right? So you have only 2 dates from now till now. 2003 to 2009 is not possible. Next is 2010. Is that possible? So what is it going to be? 01, 02. This is possible, right? This is 1st February 2010. This is possible. 2011, 1102. 11th February, possible. 2012. This is going to be 2102. This is also possible. After this, nothing is going to be possible, right? 13. It's going to become 31. So February doesn't have 31. 14, 15, 16, 17, 18, 19. None of these is possible. You have to go on up to 2020. So what happens in 2020? 2020 means 0202. This is possible, right? 2nd February. So how many dates have become possible? 1, 2, 3, 4,
6.
5. That's it. So you just start with the year and then you look for the dates that are possible and then you're going to get the answer. So these are all questions that you should definitely attempt, because these are going to take very less time for you to solve. You just have to write down the possibilities. Okay. The bar chart shows the solubility of 5 species of noble gases in a solvent. The ratio of the solubility of helium and krypton. Helium is given here, solubility is given here, krypton is given here. So you have to find the ratio. So you just have to divide whatever this number is divided by this number, right? So you have 10 power minus 6 going on up to 10 power minus 3. So you have to see what is the number of lines between 10 power minus 6 and 10 power minus 5. Then you will know what is this exact value that these are pointing to. Right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 lines in between, means including this. So 10 lines. So what will this line correspond to? If this is 10 power minus 6 and this is 10 times 10 power minus 6, what will the second line correspond to? 2 into 10 power minus 6, right? Each line is going to correspond to one value. And then the 10th line is going to correspond to 10 power minus 5. That is 10 into 10 power minus 6. Right? So you just have to pick what is the number. So what is this line? 2 into 10 power minus 4. 10 power minus 4 is this. This is 10 into 10 power minus 4. So for helium, it is 2 into 10 power minus 4. What about krypton? Ratio of solubility of helium to krypton. So helium is this, krypton is here. 2, 3, 4. 4 into 10 power minus 6. That's it. Whatever is the answer. 10 power minus 2. So that's 10 power 2. 2 by 4 into 100. 200 by 4. There's no simplified answer. So 200 by 4 is the answer. Right? Is it clear? Yes, are you all still with me?
It is very clear.
Yes, ma'am, clear.
Okay. Fine. Yeah, and then you definitely get such puzzles also, where you just have to change the orientation and find out which is the correct which is the figure that matches and all that. So these are also simple questions which you should definitely attempt. Which of the following figures matches exactly the figure below, but for orientation? So you're rotating this figure in whatever direction and all that. You have to find out which of the ones matches. So can someone tell me which one matches? So the circle is in 3 of the options. The circle is on the
Second one.
second one, is it? Let's check. So what happens? Circle is coming down. So this is going to rotate 90 degrees. So if the circle comes down, this triangle is going to come up. Triangle is going to come up and the 90-degree rotation. So it will look like this, right? Okay. And then the empty square will be here. And then this portion will be here. Right next to the circle, you have the star. Right. It's going to rotate like this, right? It's going to be like this. So that is the second option, right? This one is not possible because to the right of the circle, you have the triangle, right? So when you rotate, the triangle is going to be on top. This is after 2 rotations, I guess, right? 90 and then 90, you will get this. But what is wrong here? The star. The star has to be right next to the circle. So it should have been here, not here. Right? So this is wrong. And then here, this portion is not right. Right? So you have to just make sure that the others are wrong. Sorry, this is wrong.
No, ma'am.
So option B is right.
Ma'am, for the fourth one, the star partition line has a horizontal line, ma'am, but here it is vertical.
Oh, okay, okay, okay. And the fourth option is 2 rotations. Oh, right. So however this is, it's going to be just flipped, right? So the line has to be like this. The line has to be here. The star is, okay, the star is right, but the line has to be like this. Okay, fine. Thank you. Okay. So these are simple questions that you should definitely attempt. Okay, next one. A piece in a board game starts at the center of the board having 5 cross 5 squares. Okay, there's a 5 cross 5 square. And then it starts at the center. A piece can be moved 1 square horizontally or vertically in one move. Okay, so the piece can go only 1 square up or down. Okay, if all its moves are random, The chance that it will be in one of the 4 outer squares at the end of second move is. Okay. So which are the possibilities for it to reach the end outermost square? So it can go one step to the right, and then the next step also should be to the right. Only then in 2 steps it can reach the outermost square, or one step above, next step also above, one step to the left, next step also to the left, one step to the bottom, and then the next step also to the bottom. So how do we calculate the probability of it being here? What is probability? Probability is favorable, number of favorable outcomes divided by total number of outcomes, right? So what is the total number of outcomes here? What is it that we want? What is it that we want? What is the total number of outcomes here? The total number of, what you want is you want the piece to be in the outermost square, right? That is the total number of outcomes. It can be anywhere here. That is what you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 5 plus 4, 9 plus 4, 13 plus 3, 16. Right? The total number of outcomes is 16. But what are the only possibilities which are possible? In 2 moves, how will you reach there? So you cannot reach here in 2 moves. You cannot reach here in 2 moves. Similarly, you cannot reach any of these spots in 2 moves. You can reach only these spots in 2 moves, right? That is 4 of them. So those are the favorable outcomes. So 4 out of 16, that is 1 by 4. So this is a probability question. If you find it difficult, you can ignore this. But this is again just logic. So you can just do this. Okay. And then you definitely get Venn diagram questions, which should definitely not be ignored, because these are very, very simple questions that you can get. An appropriate Venn diagram to represent the relationships between categories inflammable substance, water, petrol, and liquid. So inflammable substance means something that catches fire, right? So petrol comes under this category. Water does not come under this category. Liquid, is every inflammable substance a liquid? No. You can have solids that burn, right? For example, matchstick, crackers, and all that, right? So you just have to look at what is appropriate. So is water an inflammable substance? No. So there should be a box which is completely away from one of the boxes. Okay, that's happening in all the options. And water and petrol. Water should be inside, completely inside one of the objects, and then petrol should be completely outside. Means there should be 2 boxes which is something like this. There is a box inflammable, and then petrol will be inside it, and water is completely outside it. Is that happening everywhere? Kind of happening, but it's not matching with liquid, right? So water and petrol should be inside liquid, right? So this one, if this is liquid, this is inflammable, this is petrol, and then this is water, everything matches. Here, does it match? Since it's only one right answer, if you're able to find the right answer, that is enough. You're done with it. So this is not an option at all, right? Because not everything comes inside one or the other. Inflammable substances, there are solids as well. So this is definitely gone. Here, okay, you can treat this as liquids and inflammable. And then, oh, okay. So there is if this is petrol, then this is not going to work because petrol is completely liquid. It has to be inside the liquid part. So this is not right. And then here again, Similarly, you can rule out this option as well. So this is the right answer. So for the Venn diagram question, you just need to figure out what is the relation between the given objects. That's it. Okay. Machine A cuts rods whose mean length is 10 centimeter with a standard deviation of 3 millimeter. Okay. So you have a 10 centimeter rod and then a standard deviation of 3 millimeter. What does standard deviation say? What does average say? What does standard deviation say? Mean is average, right? What is mean and what is standard deviation? How are they different? Are they referring to two different things? Okay, so mean is, it's a central value in the sense that you have a set of values. You're trying to somehow figure out something, some central value which talks about the entire set of data. That is mean, average. Standard deviation or variance talks about how far the data is spread from the central value. Now that you have a central value, how far the data is spread from the central value, that is variance. Square root of variance is standard deviation. So whenever standard deviation is given, you should always find the variance first. So 3 millimeter means 9 millimeter. And okay, since everything is in, you have to convert everything to 1 unit. You should make sure that that is not an error that you're causing. So 10 centimeter is what? 100 millimeter. And 20 centimeter. Machine B cuts rods of mean length 20 centimeters. So 200 millimeter with a standard deviation of 4 millimeters. So the variance is 16 millimeter. Rods of 30 centimeter mean length are made. Okay. So each by joining one rod from each machine. So you have one rod from A and one rod from B, and then you join it to get 30 centimeter. The standard deviation in the length of the joint rod is. So basically you are asked for standard deviation of joint rod. So that is square root of variance. So variance of A plus B is asked. What is variance of A plus B? Variance of A plus variance of B, right? So you just have to do this. Variance of A is 9 millimeter plus 16 millimeter. So this is what? 25, 5 millimeter. That's. Or if you don't know that variance of A plus B is variance of A plus variance of B, even by logic you can do. So machine A cuts rod's mean length is 10 centimeter with standard deviation of 3 millimeter. That is variance is 9 millimeter. So that is the range of the size from the central value, how far the value is scattered. The values are scattered, right? That is what variance talks about. So from 100 millimeter, you have a variance of 9 millimeter. That is 100 minus 9 is the left end point, comma 100 plus 9. This is the length of rods that are cut by machine A. It can be at most 109 millimeter, or the smallest it can be is 91 millimeter. For B it is 20 minus, okay, 200 minus 16, comma 200 plus 60. So if you want to find out what happens to the total length, what will you do is, you'll first add, this is for A and this is for B. So first you will see what is the least possible. The least possible of A plus B is the least possible of A plus the least possible of B, right? So 91, 200 minus 16 is 190, 184, right? Come on. 260, 109 plus 260. And you also know what the mean is. The mean is 30, 300, right? So what is this? 5, 7, 2. 275. So this distance from the mean, it is 25. So this side also it should be 25. 15, right? 320, right? So there is a difference from 300. There is a difference on the left side of 25 and the right side of 25. So the variance is 25. The variance for the sum is 25. So the standard deviation is 5. Even if you don't know that variance of A plus B is variance of A plus variance of B, just by logic, you can solve this problem. Okay. So there'll be questions of this kind where it will be based on certain facts and all that. So if you know, you can attempt. Otherwise, it's better to ignore such questions because we don't know whether we are absolutely right or not. If all the planets in our solar system were to move in the same plane, it would necessarily imply that the sun is at the center of the solar system. The visible planets will appear aligned along a straight line in the sky as seen from the Earth. Motion of planets is governed by Newton's law of gravity. The radii of the orbits of the planets are in harmonic progression. Okay, to be honest, I have no idea what the answer to this question is and how to approach as well. But this is a fact-based question, so there is no logic that we can apply to this. So it is better to ignore such questions because it'll be a gamble, and there is a 3 out of 4 chances that we are wrong. So such questions can be ignored. And does anyone know what is the answer to this question and the logic behind it? We've already seen. Anyone? Okay, if not, let's proceed. An experiment is done to count the number of small grains that make up a level scoop. Okay, you take a scoop and then you take a level scoop. That is, you level it up and then you're counting the number of grains in it, taking adequate precautions. If the measurements are repeated several times, which of the following frequency distributions is the most unlikely to occur? So which one is it? Just by looking at the graphs, you can answer. Which one is the most unlikely to occur? Anyone? Every time you pick a scoop, you take grains in a cup or something and then you make sure that it is of the same level. The number of grains in it need not be the same all the time, right? Every time you pick, it's the same number of grains is not possible, right? So this is the one which is not possible. You can think of rice also, right? You just take some rice you take a handful of rice. Every time you take the handful of rice, you need not have the exact same quantity of grains in it, right? So this is the one that is the most unlikely to happen. It may increase, decrease, and all that is possible. But every time you get the same number, that is not possible. That is the most unlikely to occur. So the chance of such an occurrence is very, very low. So such questions are also, you will also get such questions which are very, very simple, which should definitely not be ignored. Okay. Two windows of a building are exactly one above the other. So you have a window, one above the other, and their lower edges are 2 and 4 meters from the ground. Okay. So if this is the building, this distance is 2 meters, and the lower edge of this is 4 meters. Okay. The distance between these two is 2 meters. Means not these two. This lower edge and this lower edge. This is also 2 meters. The angle of elevation of the bird. Okay, so there is a bird. It's flying somewhere. From the lower edge of the lower window. This is the lower window. This is the upper window. The lower edge of the lower window. From here, if you look at the bird, the angle of elevation is what? 60 degrees. and that from the lower edge of the upper window. So this is the upper window. And from here, if you look at the bird, it is 30 degrees. Okay. How high is the bird from the ground? So you have to calculate this distance. We know this distance, this is 2 meters. We know this distance, this is 2 meters. So if we calculate this distance, then we are done. So let's call it x. I guess we have done a lot of trigonometry in school that deals with such problems, right? So for this x, you will take, all this base is fixed, right? You can call it some y, y, y. So from the first triangle, tan 30 is x by y. So 1 by root 3 is x by y. From the second triangle, tan 60 is opposite side. Opposite side is the entire side here now. So x plus 2 divided by base adjacent side. So y. So root 3 is x plus 2 by y. You just have to eliminate y because y is not known. You eliminate y and then find out what is x. That's all. So y is root 3x from the first equation. Y is, okay, root 3y is x plus 2 from the second equation. So root 3 into root 3x is x plus 2. So just solve for this, you'll get x. 3x, 2x is 2. So x is 1. Right. So if x is 1, the height is 1 plus 2 plus 2. 5. Yeah, we have 5 meters. Everything is in meters, so nothing to worry. So 5 meters. Okay. At a particular location, a mobile app shows that there are 6, 13, 28, and 50 infected persons with radii 1, 2, 3, and 4 kilometers respectively. Within which radius is the density of the infected persons the largest? So what does density mean? Population density. What does density mean? Does anyone want to answer? Density is what? Basically mass by volume, right? In fact, when you talk about population density, you talk about how many people are there in a particular region, right? So what is it that we have to calculate? In a given area, region, how many people are there? So which is the most crowded part? In 1 kilometer radius, you have 6 people. In 2 kilometer radius, you have 13 people. Which is bigger? Means which is denser? How will you calculate? Mass by volume. Volume is what? Pi r. Pi r cube. No, what? 4 by 3 pi r square h. No, that's for cylinder, right?
4
Okay.
by 3 pi r cube.
Huh?
4 by 3 pi r cube.
Ah, right. Yeah. So 4 by 3 pi r cube. Volume is proportional to 4 by 3 pi r cube, or volume is equal to 4 by 3 pi r cube. So volume is proportional to r cube, right? So you have to check that. So the density in the first circle is going to be mass is 6 by volume is 4 by 3 pi. In the second circle, that is of diameter, radius 2, it's going to be 13 by 4 by 3 pi r cube, 8. And then it's going to be similarly 28 by 4 by 3 pi. R cube is 27. And then you have 50 divided by 4 by 3 pi. 16 fours are 64, right? So you can ignore all these terms. These are the same. You're just calculating which ratio is bigger. So you can ignore these terms. So which is the biggest? 6, right? You have 13 by 8, that is smaller. 28 by 27, much smaller. 50 by 64, even smaller. So the maximum density is in the 1 kilometer radius. So most densely populated is the innermost circle. Okay. Water from a completely filled cylindrical jar is poured into smaller cylindrical jars. You have a big cylindrical jar, okay, and then you have smaller cylindrical jars. 1/10 of its diameter, but the same height. Okay. So the height is the same, but the diameter is smaller. So d nu is 1/10 of d. If this is d, then d nu is 1/10 of d. Height is the same. How many smaller jars can be completely filled? Okay, so the volume here, the amount of water here is pi r squared h, right? So pi r squared h. You have to fill pi r squared h into smaller ones. So n into pi r nu squared h. You have to find out what is this n. And we know what is the relation between r and r nu. R nu is d nu by 2. D nu is d by 10. And d is 2r. So r by 10. So this is pi r by 10 squared h. Pi r squared by 100 h. Into n should be equal to pi r squared h, so that n is 100, right? So you need 10 smaller cylindrical jars to fill the water from the big jar completely. So these are simple problems. Just by simple logic, you can solve these problems. These are what we would have studied in school. Okay, again a graph question. The graph shows the day-on-day changes in a certain index. Okay, which of the following is the correct graph for the rate of change of the index? So which one is it? Rate of change. How do we calculate rate of change? If there's an increase in volume, the rate of change is, means if there is an increase in this, the rate of change will be positive, and if there is a decrease, the rate of change will be negative, right? So which of the graphs is the correct answer? Can anyone tell?
Ma'am, option D.
Option D. Okay, let's check. So first, from the first point to the second point, there is an increase, slight increase. So it has to be positive. The first point has to be positive. So the option B is ruled out, right? Because it says that it is negative here. Rate of change is negative. That's wrong because there is an increase. Okay, the others are all positive. Fine. And from the second point to the third point, there is a decrease. So the second point in rate of change should be below the thing. Oh, so D is gone, right? This should be below, right? Because second point to third point, there is a decrease. So in the rate of change graph, it has to come below the line, right? It has to be negative. So D is gone. And then again, there is an increase. So the third point has to be above the graph, in the positive part. Okay, it is in the positive part in both. And then there is a decrease again. So next it has to be in the negative part. Yes, it is there. And then there is an increase. So it has to be in the positive part. So this is the right answer, right? Because what it says here is the rate of change is 0. If rate of change is 0, then this point after that, then the next point has to be here. But that's not what is happening. It is moving above, right? So there is a positive rate of change. So this is not right. So this is the right answer. Is it clear to everyone how option A is right?
Yes, ma'am.
Okay, so that's it with this question paper. So see, again, my aim was not to tell how to solve part A questions. I'm no expert in that. So my aim was to just let you know. Probably you won't even practice part A, right? So at least if you have seen part A of previous questions and all that, you would probably realize that it is not that difficult and you can also attempt. I'm not telling that when you are going to give the exam, it's going to be as simple as this. It may be easier than this, in which case you can score more. It may be more difficult, in which case you can score less. It doesn't matter, but you have to take the gamble. You have to at least look at the questions so that you will know that you might get marks even from there. Like I had got 27 marks in part A out of the 30 marks possible, which is like, that's going to boost your marks a lot. And I cleared net for the first time when I was in my first year of MSc itself. I didn't put any extra effort to study anything from the second year syllabus or anything. I had just studied whatever was there in the first year syllabus. And then with this 27 marks, with that itself, I cleared net. So it is going to be a big booster to your rank, or at least in your passing criteria.
Okay, thank you, Sushmitha, for this nice session.
Thank you, sir.
Okay, now it is time for feedback. Dear participants, please share your feedback.
Hello, ma'am.
Hi, Arya.
My name is Arya, and this was very nice section, ma'am. And we can get an idea to how to approximate this kind of questions and how to solve this. And it's very helpful section, ma'am. And thank you for your valuable time, ma'am.
Thank you. Another thing is you needn't spend more than half an hour on part A. Because you also need to, you would have come prepared for part B and C. So definitely you should give more time to that. But at least 15 to 20 minutes you should spend on part A, because you may get a lot of score here as well.
Okay, ma'am.
Thank you, Arya. Others?
Hi, ma'am.
Hi.
I'm Hridya. I'm doing my first year MSc in Kerala School of Mathematics.
Okay.
So the session was very nice. I enjoyed it a lot. And as far as I understand, the key things that you need to look for, you need to have the key skills you need to have for cracking a competitive exam is the small tricks with which we can utilize the limited time in the most productive way. So attending your class gives me the motivation to all the, I mean, the skills, the tricks and all, basically for the part A, which will be really helpful for me in attending the exam also. So thank you very much, ma'am.
Thank you so much.
Thank you, Hridya. Yes, others?
Hi, ma'am. Good morning, ma'am.
Yeah.
Ma'am, I'm Nandakumar from Tamil Nadu, ma'am. I am pursuing my research, ma'am, Ph.D, ma'am. I have attended your last session, that is in June month. And after that, I have attended the CSIR net exam, ma'am, and I have scored 24 marks in part A with no negative marks, ma'am.
Thank you so much. That's such a nice thing to hear.
Thank you for your previous session, ma'am. And your previous session and this session is completely the same. It means you have taught the same ideas, and it means your level is not decreasing, ma'am. You are teaching the same level of motivation, ma'am.
Thank you so much.
Thank you, Nandakumar.
With your previous session, I have scored with no negative marks. Without your session, it may not possible, ma'am.
Thank you so much.
Thank
We didn't
you, thank
discuss.
you.
Yeah, we didn't discuss how to means the, yeah, my main aim is to motivate you all to attempt part A, because I know a lot of my friends who don't even attempt part A. Yeah, it is possible to clear just with the math part, but this is going to boost your score. That is the main idea.
The main thing is I have not prepared for a single question for part A, ma'am. With only I have gone for the exam with your video, with your only one session.
Thank you so much.
Thank you,
Thank you very
Nandakumar.
much, ma'am.
Yeah, for your nice words. Thank you. Yeah. Others?
Good afternoon, ma'am.
Hi, good afternoon, Shekha.
Ma'am, I'm Shikha and I'm preparing for CSIR NET. I've completed my MSc from Birla Institute of Technology, Meshra, and I'm from Jharkhand. Ma'am, your session was really very nice, and the motivation that you gave today to attend part A was really great, and I got a lot of motivation to practice such questions. Thank you, ma'am, for this useful session. Thanks a lot. And thank you,
so much.
Vinod, sir.
Thank you, Shikha. Any others?
Good afternoon, ma'am.
Good afternoon.
Ma'am, I found the session really interesting. Even though I'm not an ETH student, I'm a BSc student. But I found the session interesting and I was able to follow the questions which you explained. Thank you, ma'am, for the session. Thank you, Vinod, sir, for conducting the session. Thank you.
Thank you.
Thank you. Thank you, Gopika. Others?
Good afternoon, ma'am. I am ℚ𝕒𝕣𝕥 from St. Peter's College, Kolancheri. Today's section was very interesting and it helped me a lot to solve the problems. And thank you for your wonderful lectures and discussion. Thank you, Vinod sir, for arranging this class. Thank you.
Thank you.
Thank you, Elsa.
Hello, ma'am. I am Riza. I am a BSc student. The whole session was really helpful and understanding. Thank you very much, ma'am. Also, thank you, Vinod sir.
Thank you.
Thank you, Elsa. So if any of you would like to share a feedback, you can do it now. Otherwise, yeah, Patna. I think some technical issue from your side. The voice is not coming, I think. Yes. So thank you, Sushmitha, for being with us for the, actually it is the third time you are engaging a session in our platform. So I'm very happy there. So thank you for your support to our initiative.
Thank you so much, sir. And thank you for helping out so many people.
Okay, thank you very much. Let us wind up here. Bye.
Bye. Bye, everyone. All the best to everyone who's going to write the exam.